All right, in this lesson here, what we're going to do is take a look at creating the Sprite class. This is really the base class, if you will, for everything that moves, as Dan likes to say.
Yep.
That's our hero. That's our
Fireball.
evil monkey. It's our fireball.
Fireball.
And if you remember, all the way back in the introduction, when we took a look at the concept of data flow and all of the different elements.
Picture.
The big picture. I was trying not to say that, but okay, the big picture. We had a Sprite class, and inheriting from the Sprite class was our hero and our fireball and all that good stuff.
Yep.
So, Joel, go ahead and start walking us through the things that the Sprite class is going to be responsible for.
Kind of just read over what I have here. A sprite, as we said before, is a 2D image that is drawn on the screen. There's different things that it has, different attributes. It has a position, a certain number of lives, a Sprite Index, which is what we talked about when we did the draw engine.
Yeah.
It has its own specific unique ID.
Yep.
And we have the class ID. I shouldn't have said ID, because class ID here is saying, is this a sprite? Is this a fireball? Is this a character?
It's a way for us in the future to differentiate
between the
classes that we've inherited.
Right, because remember, a character is inherited from a sprite.
Yep.
A fireball is inherited from a sprite. Well, we're going to need to somehow differentiate between these guys.
Yeah, later on when we start integrating everything, it's important.
That's right. And finally, it can draw itself. So we're going to have access inside of the sprite class to our draw engine so that we know how to draw certain sprites.
Yep. Everyone that moves is responsible for drawing themselves.
That's right. And down here, if we start right here, you'll notice we need a way to get the current position of the sprite. So we're going to be creating 3 accessor functions. The get position, which is going to, well, do what exactly, Dan?
Get the X and the Y.
Isn't that difficult?
No.
No. We have get X and get Y. We also need to know how to add and remove lives from the sprite, because remember, we have lives for each of our sprites. If we're out of lives, the sprite should die.
Yeah, the sprite could start off with, say, 3 lives,
yep.
which our character will eventually do.
Mm-hmm.
And as it gets attacked by an evil monkey, we can decrement the life. So we'll have 2 lives, then 1 life, and then no lives, which
yep.
means the game's basically over.
Right. And then from there, we need to check to see if the sprite is alive. So we just create an isAlive function that just returns a bool, which is true or false. And then from there, we need ways to move the sprite. So we have a move function that says move here and here.
Yeah, we'll be able to move a certain amount of spaces, either left, right, up, or down.
Based on its current position.
Based on its current. This does not draw, however.
Right.
It just moves. It updates the position information in the sprite class.
Right. We also, every sprite has a direction.
And this is important.
This is important when we come to dealing with, like, the fireball.
When the character fires, which way is he going to fire?
That's right.
Which way is he facing, basically?
Yeah, so we need to specify this in the move functionality so that the facing direction is updated when we move our sprite.
Exactly.
And we also have local functions to erase and draw the sprite, and it uses the draw engine. So basically, it's just going to call draw sprite.
Yep.
Or erase sprite, either or. So then we have the idle update function, which allows us to do special sprite processing during idle time. Dan, this is an important thing.
Yeah, when we start adding creatures onto our level, we're going to make ourselves a little structure, a little list of creatures that inhabit it, and we're going to be able to loop through it. And during idle time, we can call this function. So we'll be able to do animation like move a fireball,
right,
or have the enemies seek and destroy the character.
AI processing that we need to take care of at that point.
Right.
If we include this function, it just gives us a way to expand our functionality in later classes.
Yeah.
Which is important.
Yes, it is. So I guess that's pretty much it. So why don't we go over into our .NET here, dink, and start building it up.
Go ahead and jump back over to the Solution Explorer real quick, and we'll start out with a header file.
Right, for our sprite. Let's see if I can do this right this time. So, header file, and this is going to be Sprite. Open. Yes, so here we have our Sprite header file. And of course, the first thing we need to do is preprocessor definition. Sprite H.
If it's not defined, define it.
And the if. So inside of here, we're going to create the class Sprite. Dink, dink, and semicolon.
Semicolon.
Yes,
he remembered 2 times in a row.
Aren't you impressed?
Boy, cookie.
I want a cookie. So the first thing is the constructor. So same name as the class. And the first thing we're going to pass to the constructor is the draw engine pointer.
Yeah, we don't want to keep creating a new draw engine for the whole game.
Yeah, that would be bad.
Every single class, yeah.
So we're just going to pass a pointer, which the game class is going to pass to us, right?
Yep.
So we're going, yeah.
And this also means we're now going to need to be aware of the draw engine inside this header here.
That's right. So first, we're just going to say draw engine. It's going to be a pointer. We'll just say D, which is draw engine. and then an integer s underscore index, which is the
Sprite Index.
right. So which one we want to draw?
Yeah, so if we happen to be drawing the hero, that will be a 0. If it's an enemy, we'll have it be a 1,
That
et
kind of
cetera,
thing.
et cetera.
Right.
Yep.
And of course, when we call create sprite, it's going to give us another unique index.
Yes.
But in our case, in this case, it's going to return the same index, isn't it?
Yeah, because of the way our functionality is working inside of the
Draw engine. Right. Then from there we have our float, and I'm just going to have it default to 1 and 1 and x and 1.
That's going to be a start position on the screen.
That's right. So set that up, and for number of lives, you know what? I'm going to have him start out with 1 life. That makes sense. And of course the destructor. So we have the destructor set up here.
Mm-hmm.
And let's see. Remember, if we switch back over to Notepad, I do kind of like having this up here so we can show you. We have these 3 functions that we need to create, right?
Mm-hmm.
But we also have some variables that we need to have, some local variables. So let's go ahead and create these 3 accessor functions along with the necessary variables.
Okay.
So let's go back into .NET here. And
Is it kind of a good idea for a complete beginner, like in this case right here, where in the constructor they're using draw engine, to go ahead and at that point, since you know you're going to be using it, just include it?
Yeah. So we can include...
Just so you don't forget about it 10 minutes later.
Yeah.
And
Of course, if you do forget about it,
it'll let you know.
It'll let you know.
How
Yeah.
kind of it.
Yeah. So, the definition for our get position, it's going to return a vector. Now, by now you should know the vector is not a default type.
No.
So, what we're going to need to do is define what a vector is. What is a vector? Vector has an x and a y.
Yep.
So we can create a structure.
Yeah, we're not going to be using the class that we developed earlier. We're
No,
gonna
that's
just
that's
be using
overly
Destructor.
robust.
Yeah.
Well, for our case, we just need to hold 2 variables, x and y.
Yep.
So, inside of our vector, we can hold float x and float y. Simple as that. So our get position is going to return to us a vector. And inside of here, we're going to have our get x, which just returns a float.
Yep.
We don't need to pass it anything, so it's going to be void. And get y, which is going to return to us the y component. Now, we're going to create this as protected. This is where our variables are going to go. What do we need? Well, we need an instance, not an instance, a pointer to the draw engine.
Yeah, because the draw engine is going to always live in the game class.
That's right. So we can say pointer draw area. Now we also need our position, which is going to be a vector. So vector POS. We also need the sprite index, which we're going to use in just a second. So that's sprite index. And finally, we have our number of lives. So for now, let's just keep it at that.
Okay.
Now let's create our source file and implement the functions that we have so far. So create a new item. It's going to be the CPP file, and we'll call this guy Sprite. So inside of here, first thing, include the sprite.h file. And inside of here, what we're going to do is say sprite, and then create the constructor. No.
The constructor.
Thank you.
You're welcome.
Draw engine, D, and then float x equals, no, yeah.
Yeah, you can only have the default values in one area, and that, in our case, is in the header file.
That's right.
Yeah.
So, how do we initialize this? This is the easy, fun part.
Oh, I love this function.
Yes, this is fun.
Yeah.
So, the first thing we're going to do is just say draw area equals DE.
Yep, because
Ooh.
we're going to be assigning a pointer to a pointer.
That's right. For the position, we can say position dot x, because remember, we declared it as a vector, which is a structure which we can access the individual components via the dot operator.
That's right.
Whew, that was
well done.
Thank you.
Yeah.
Now, the sprite index. The way we can access this is just say sprite index equals s underscore index. The reason we need to do this in another circumstance, like when we do our port.
Yeah.
Okay, I just want to kind of reference it just a little bit. We're going to change this around just a little bit because we want the create sprite to return us a unique value.
Yeah, and in this DOS version, we really only need one value, which represents which index it is in the draw engine.
That's right.
Whereas when we do a port, each sprite has a unique number.
That's right.
It's just a platform dependency issue.
Yep.
Which we're developing right now for the Windows DOS application platform.
So sprite index equals s underscore index, and num lives. This is easy. Num lives equals I underscore lives, which defaults to what, Dan?
1.
Yes, he actually remembered. And class ID. Now, In this case, what is our class ID?
Well,
Sprite class ID. We want it to be the Sprite class, right?
Mm-hmm.
Well, a good way to do this is to declare an Enum type. Now,
have we ever talked about
we
the
have
enum
never
type
talked
before?
about it. So, Dan, give us a little intro.
All right, an enum type essentially is a structure that lets you specify variable names and assigns values to them as 0, 1, 2, 3 in order.
So sequentially.
Sequentially.
So what we could do here is just say enum, and just like a structure, curly braces, followed by a little bit of a semicolon here. And inside of here, we can declare the different names. So we could have Sprite underscore class ID. So we can now refer to this as Sprite class ID, and it's going to return to us the value 0. If we put another enum here, enum type here, like let's say Fireball underscore class ID.
It would become 1.
It would become 1, but we can use the name Sprite class ID. And that just makes it a whole lot easier than just saying, well, this class ID is 0.
Right, well, it's just because it's descriptive.
That it's descriptive. It's actual text that we can look at.
And the best part is say we ever happen to move around these IDs, we don't care what the value is.
Right, we
only
don't.
care about the name.
Yep.
Right.
That makes it a whole lot easier if we wanted to change the order of these. So, back to our CPP file, we can say equals Sprite underscore class, ID. So, that should be the constructor. Simple as that. Now, which is the next function? Let's create the Destructor.
Okay, did we define that already?
Yes, we
right?
did.
All right.
So, inside of here, we can say Sprite, and Sprite, this is going to be the Destructor. So, no arguments. Inside of here, we only need one function, and that is erase. Now, we have not defined erase yet.
So how about instead of actually writing the code, we just put in...
Erase the sprite, the dying sprite.
Yeah, because in this phase, the sprite would actually be dead, so to speak.
Right, so we want to erase anything that's left.
Yep.
That makes sense, right, Buzz?
Yep.
All right. So the next thing we want to do is create the accessor functions that we have, get position, get x, and get y. So get position returns a vector in the sprite, and it's called get position. And we're obviously not going to pass it anything. And this is hard. Return POS.
I love accessor functions simply because they're usually easy to program.
Right.
But at the same time, you, as a programmer, probably hate accessor functions because they're so easy to program.
Yeah.
It's sort of like you wish they'd just be automatic because it's really only 3 lines of code, 4 lines of code.
Yeah. That is very true.
You know, every class, if you're going to have variables, it's usually a good idea to put in accessors.
And at times, you could have accessor functions that are actually more complicated than that. You actually have to do some processing before you can return it to the user.
That's true.
So return POS.y. That is our accessor functions. Now, let's go back to our header file. Let's see. We have these functions all defined. Now,
so according to what we have in our general outline.
Yeah, let's go back to our big picture just for a second.
So we've done
Get back in focus.
Yes.
We've done this top area down to need to add and remove lives.
Right. We've already done pretty much all of this.
Yep.
Now we need to add and remove lives from the sprite. So let's go back to our evil monkeys. And let's declare some stuff. The first one is going to be add lives. And we're going to declare this as virtual. Now, explain to me, Dan. What's virtual?
Oh boy, here it comes. Okay, virtual is a way that we will allow future classes that we derive from Sprite. So in this case, the enemy, character, mage, fireball.
So anything that inherits from this
anything
class.
that inherits from this class. A way to override the functionality and actually have it be called to the class that is overriding that functionality.
Right, so that especially when we're dealing with pointers, it makes it a whole lot easier. Otherwise, it may call the wrong function.
Yep.
But by saying virtual, it says it's a virtual function, so I want any class that inherits from this class to declare it, and we're going to use the one that was created that's new, not the base class function.
Yeah, so if we have an enemy class and we call add live,
right,
it's going to call that
the
class
is
a add life function instead of the base class's Sprite's add life function.
Right. Whew, that was hard to get out.
That was a mouthful. That last
Yeah.
Yeah. So we have add lives, and all we need to do is return to have the parameter list as number of lives to remove.
So what's going to happen is we can either add a life, which means if we had 3, we can make it 4, we can make it 5, we can add anything. But what's cool about this, we can have a negative number.
So we can say add lives -1, which means we're removing a life.
Yeah, which means if we had 3, it becomes 2, and so on. And
yeah,
so
very
forth.
cool. Now we have to have another kind of accessor function called getLives, just so we know where we currently stand. So int get lives. Another thing is bool is alive. And we're just going to not pass in anything as well. Is alive just returns true or false.
Yep, it'll check to see if you have 0 lives. No, you're not around anymore.
And another thing that we could do here, we're going to implement these now. Copy these 3 and just paste it in here.
Ooh.
Now what we can do, it just kind of makes life a little bit easier. Now, Dan, do we need the virtual here now?
No, the virtual keyword is only existent inside the definition of the class.
Kind of like this right here.
Yeah.
The
It's
default.
only done once.
It's only done once. So inside of here, sprite, add lives. And this one's a toughie. Num lives plus equal num.
Ooh.
Pretty tough.
Yeah, that's pretty difficult.
Oh, yeah.
Yeah, alright. Once you guys get over that, just let me know. So sprite, get lives. And
Yeah, get a life, Joel.
I'll try. I've been trying to get a life for a long time now. I've been failing. Inside of here, sprite. Sprite is alive.
And now we have to do some sort of return processing.
Yeah.
Okay.
How would you like to do that?
I would like to do it with if statements. I know Joel doesn't want to do it with if statements.
I'll do it with if statements just to make you
happy. In other
happy.
words, if we have some number of lives...
Yeah, if it's greater than 0.
Is less than or equal to 0.
Or that way.
We can return false.
False.
Or we return true.
Yeah.
Now
Joel,
the other way to do it, which is a whole lot better, is return num lives is greater than 0.
That does work.
Doesn't that work a whole lot better?
Yeah, that does work a lot.
I'm going to keep this in here just to make Dan happy, but I'm going to use the clean code. Say Dan's
Dad's
code.
Dad,
Isn't that sweet?
Yeah.
All right. So there our accessor functions are. Now we get to the actual interesting code. And that's if we come back down to our big picture, we've implemented all of these guys here, right?
So now we have a position, we can get it.
Yep.
We have lives, we can add, we can subtract, we can
do all
that stuff. Okay.
We got to move it.
Now we got to actually do what a sprite is meant for, moving it.
That's right.
So let's go down back to .NET and create this move function, this magical move function. Now this is going to be a virtual function as well, and it's going to return a bool. Why is that, Dan?
Well, it's going to return true or false depending upon if it moved.
So if it moved, it's going to return true.
True.
It's I moved.
If it didn't move, it'll return false.
Okay.
And this becomes important when we start wanting to move around a level.
Mm-hmm.
Right now, we're not worried about that functionality.
Right.
But say we're going to move, or we want to move in one direction, and there's a wall in our face.
Right.
We can't move.
Yeah. So we're going to return false.
We'll return false. But if we were able to move, we return true.
Right. So we'll save this, go back over to our CPP file here, and we'll just say bool sprite move, and then float x and float y. Inside of the move function, what are we going to do? This is difficult. Position.x plus equals x.
Yeah, the concept, of course, is
y
wherever our original position was, we want to move so many places left or right, so many places up or down.
Right.
From our current position.
Mm-hmm.
It's not an absolute coordinate on the screen. It's all relative.
Yeah. But at this point, we could also do the drawing of it, right?
Yes, we could.
Actually, that is what we want to do.
Yeah, because the idea behind the Sprite class and every movable object is that it draws itself.
Right.
And because this is the function that outside functionality will call to move it, it makes sense to draw it here.
That's right. So what we want to do is say, call our erase, our draw engine's erase right now. But we haven't created our own erase function.
Right.
So this is kind of important to implement first. So I'm going to just put here erase sprite. Well, actually, let me move this up here. Before we move it, we're going to erase it. Then after we move it, we're going to draw it at its new position. Whoa.
Or open a new application, one or the other.
So draw sprite. So that's good enough, right?
Yep.
So we can come down here. And now, which one are we going to create? This is going to be our erase function. So let me see. Let's see. Void draw. However, this is only necessary to be...
Do an erase or draw?
I'm sorry. Did I say erase?
Yeah, we're going to do them as a unit. Let's say that. So we'll do them together.
Right. So void draw, and then we're also going to void erase.
Now with draw...
Yes?
No, I'm sorry. I got a little confused for a second.
Oh, that's scary.
Yeah, we're going to be calling the draw engines functionalities for drawing and erasing. So I was thinking to myself, oh, wait, we have to pass a ID.
Right, but
that's internal in the class,
is internal.
so we don't have to do that at this level.
Right. And another thing that we can do is these two, do we really need anyone else that's outside of us to call these two functions? No, not really.
It's just self-contained, so it doesn't need to be so public.
That's right.
So it could be protected?
Yes, it can be protected or private. In fact, we'll just leave it as protected.
Okay.
That's fine. So now we have our draw and erase functions. So let's copy these two guys, go over to our source file, and implement these. Ding, ding, ding. All right, guys, this is where you're supposed to talk.
So, Dan, how about that weather today?
You know, it was really nice for a while.
It was.
Yeah, and then it got cloudy again.
It did.
You know, the birds were chirping, though.
They were.
They were pretty nice.
All right, back to the real world.
Okay, so back to programming land.
Draw area. Since we have our draw area, and it is a pointer, right?
Yeah, we're going to have to use the arrow notation.
Ooh. So draw sprite. And what index? Sprite Index.
This was what we set at the beginning in the constructor.
That's right. All of it's coming together now. So Sprite Index, XY. For our erase, this is going to be hard. Think.
Okay.
Draw. Oh, wait. I forgot to. I was like, why didn't it pop up?
Oh, okay.
Draw area, and then erase sprite.
X,
and
y.
then X and Y. And some people may be asking, well, why did you declare your own functions for draw and erase? Well, it may be different for certain areas of doing it. So you may want to say, well, for the sprite, I want to draw it this way, using the draw engine's functionality.
Yeah.
So that's the reason why we're doing it this way.
It's called, you can think of it, the technical term is called a wrapper function.
Mm-hmm.
We're wrapping the functionality of the draw engine
into ourselves. Yep. So now, with our comment here, we can just call erase X, Y. No, I'm sorry, position. Ooh, I almost got myself there.
Yeah.
Position.x and position.y. Remember, X and Y is what's being passed to us.
That's the amount we want to move left, right, up, down.
Yep.
And position is where we are in the world.
Right. So we want to change this to draw X, position.x,
Twice.
position.y. And we're going to return true, because at the moment it can't really screw up. So everything's
we
good.
have
There's
a
no wall
big
to run
empty
into.
world.
That's right. So there's only one other thing. Let me switch back to our massive picture here. Every function has a direction, doesn't it?
Mm.
We need to specify this in the move functionality. So that's where this comes in. So we need a facing direction. So come back into our .NET here, go back to our header file, and right over here we need to declare another what? What type? Come on, someone.
Another vector.
Yes. You guys are with me today. This is great.
We're only with you when you mess up, Joel. That seems to be what's going on.
Ah, great.
Yeah.
So in the move right here, what we want to do is make sure that the facing direction is updated. And this is actually really easy to do because we can say facing direction.x equals x.
Yep.
Right? Because this is just an incrementation of where we currently are, which will make it point at the correct direction.
And in our code especially, we're only going to be incrementing one position at a time.
That's right.
So if we want to move to the left, we'll be saying -1.
Right.
If we want to move to the right, it'll be 1.
Exactly.
Yeah, so
everything's just the way we want it to be. So that's set up. Another thing that we should do is in the constructor function, make sure that everything is set up correctly for our facing direction, because we should give it an initial value.
And the destructor as well. We still have not actually erased out our dying
That's right.
sprite.
So first, in our constructor, we want to initialize the facing direction, just so that everyone's happy. So right here, it doesn't really matter too much where you put this, but we'll just put it right here. Facing direction.x equals, let's say it's pointing to the right, and it's not pointing up or down.
Yeah.
It's pointing to the right.
this is just an arbitrary value that we've decided all sprites should have
Right, initially.
initially.
So in here, we're going to erase, and then we just say position.x, position.y. You know what? We're done.
Very simple.
Very, very simple.
But does it compile?
All right, so let's try compiling this guy.
Da-da-da.
Aha.
Oh, we have a error.
Class ID, undeclared identifier. You know why?
We didn't put that in the header.
No, we did not put this in the header.
Oh, that's okay.
So we're going to put int class ID. All right. Wasn't that hard?
Hey, very nice.
Now there is a few things. A few things that we should look at. Dink. It says Warning. Conversion from float to int. Possible loss of data. Remember, our x and y right now is a float.
Right.
So a good thing is to cast this so we don't get those warnings.
Yeah, and casting is just telling the compiler, I really want this to be an
I
int.
really want it. It's not a mistake. And we have 2 more here. So in the erase function, dink, we'll just change this to... It's not really... It's already converting it to an int, but this is just telling the compiler that we didn't accidentally do this.
Yeah,
we really want it to
meant
happen.
do it.
So now, no warnings or errors. Everything's good. Now let's switch back over to our draw engine. And let's add this so that we can actually start using it. I'm sorry, not our draw engine, our game.cpp.
All the way back to game.
There you go.
So, right here, we want to first create our sprite, don't we? Our player. Because now our game has 1 player, right? Mm-hmm. So in our game.h, we want there to be a sprite called player. So in our private function, we're going to say sprite player. Now Buzz, what's wrong with this picture?
We probably need to be aware of what a sprite is. So here we go with another include.
All right.
And sprite.h.
Wait.
Player.
Oh.
That was interesting.
Joel,
maybe I should ask you.
Oh, great.
Now we know what sprite is.
Now we know what sprite is, and it is calling the constructor, so everything is getting initialized accurate. But there is something that we need to do. But this should be a pointer in our case.
This should be a pointer because we have to send information to it when it's first created.
Right.
And unfortunately, inside of the header, you can't specify
it's going to call the constructor when it wants to.
Yeah.
And it's going to use all the default properties.
Yeah.
We don't want that.
No, well, we have to send it because we have to send it the draw engine.
Yeah, that's right.
And do we have a draw engine?
No.
Really? Quite? Well, no, it's kind of iffy.
Yeah.
So we'll put it inside of the header as a pointer so that inside of the game class we can use the new.
We use the new functionality. So right here at the very top, we can say player equals new sprite, and we pass it the draw engine, which we have as draw area.
Yep.
Well, actually, we need to pass it the address of the draw area.
Because we don't have it as a pointer inside of this class. We have it as a normal, everyday variable.
Yep. So we need to pass it index 0. Actually, you know what? Just for clarity's sake, I'm going to move this line right below the draw, the create sprite. So we create the sprite in the draw area. So index 0 points at our $sign.
Right.
Then when we call our new sprite, we say, this is the draw area that we're dealing with, and we want you to draw index 0, sprite index 0, which is our $sign. So that should make perfect sense. If it doesn't,
we want to make sure that the sprite knows which picture inside of the bucket to pick up.
That's right. And at this point, another thing that we need to do, we have a new. If we have a new, what does that mean?
Buzz, should we ask Buzz this one?
Should we ask Buzz?
Gee, that means anytime you use the word new, we don't want to risk a memory leak, so we got to make sure we clean up after ourselves at the end.
That's right. So we're going to call delete player. All set?
That's right.
So now, if we go back to our timer update function, now we can change this guy around a little bit, can't we?
Yeah, we could.
So let's delete this guy out here. And let's say player. And let's say move him 1 to the right and 0 in Y.
Okay.
So this should be taking care of all the drawing, shouldn't it?
It should be, yes.
So if we compile this, everything works good.
Okay, and a quick note is you did change the game speed back to what it was originally.
Oh, yes. Actually, let me go back up just to show that.
Way on up. There we go.
Right here, game speed is set to 33.33.
As opposed to 500, which we did in the last lesson.
Right. So if we come up here and let's run this. Dink! It still moves exactly the way we want to.
Drawing.
And now we get that error.
Now we get that error,
about.
which...
That's not a problem. That's
no, it's not.
That just is dealing with the way that the console works.
Right.
If we did our whole %80, if we did some checking, as in get the position, am I less than a specific value of X or greater, you can keep them
You can do all of that. In fact, let me just quit out of this for a second.
Ooh, 28.
28. Ooh.
Yeah, that's pretty nice.
One of the things that we could do is go into our sprite and limit it to a certain position, but we don't want to do that because soon we're going to be dealing with the level that's going to create an area for our sprite to play in. And when we get to that, then he's going to have walls to hit and that sort of thing.
Right.
So at this point, that's not a problem.
No, that's not a problem at all.
In fact, just to show off another thing, if we just go down to our timer update here, if I change this to, let's say, 1-1.
Ooh.
What's this going to do?
Well, if we're going to move relative to where we were, and we start at 1-1, we should then go to 2-2.
So we're moving diagonally to the bottom right.
Yeah.
So check it out. If we run this, ding.
Cool. Bonk.
Well, that's only because, again, of the way the console works.
That's right. So it's working exactly the way we want to. So actually, that pretty much wraps up what we want to show in this lesson.
I'd say so. Now, I will say this, representing the student union out there.
Student union!
And that is that several of you beginners right now may feel a bit confused because this is where we started to tie together concepts that we've looked at throughout the last 2 VTMs.
Yeah.
Right.
And it's okay. It just takes, the number one thing I recommend doing is try this. Actually do it, because typing it's going to make it settle in a whole lot more than just watching and listening to Joe go, yang, 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 right?
Thanks a lot.
So watch this a couple of times, try it out. You'll have to troubleshoot through your own typos, which is a good thing.
It's important.
But it'll make it click a lot
will.
faster, and that's really important here. But this is really... We're really getting into the start of the game now, as we now have a sprite to draw from or pull from for all of our things that move around on the screen.
What we'll find, too, is that the future code, like enemy, fireball, character, all those, will actually get easier.
Yeah, they're actually basing all of their stuff on Sprite, which we've already done.
Right.
And every future class that bases its stuff off of Sprite is going to be simple.
Exactly. Isn't that so cool?
Yeah, it is cool.
All right. So with that, that's going to wrap up this lesson. Thanks a lot, everyone.